This is a run-through of SAS JMP by Dean Palmer. SAS JMP, in short, is a powerful analysis tool that can create many different types of graphs, equations, predictions, and charts to see data from many different perspectives. Originally designed for Macintosh back in 1989, SAS JMP is now available on Windows and on Macintosh. Let's jump right into it. So, if you're going to go to SAS JMP 11, Pro 11, and as soon as you open SAS JMP, you'll see two windows that will allow you to create new data tables, and the other lets you see old data tables that have recently been opened. If you have your own data table to open, click on the new data table icon. Also can be found in the File tab up here. If you do not have your own data, you can click the Help tab and go to Sample Data, which we'll be using a lot here. From here you can click Sample Data and you can see alphabetically. We'll let you see all the different types of data they have. Lots of different data tables here to choose from. So, first thing we're going to be going over is how to use some of the simpler things. So we're going to try distribution here, but to use that we're going to need a data table, like I said before. So we're going to go into the sample data, and we're going to use a data table called exercise. You scroll down here to the E's. Made it up top. A little slow. And you see we have exercise here. So we have a bunch of continuous variables: weight, waist, pulse, chin-ups, sit-ups, jumps. First piece of data, we will use this data set to view the most basic functions in SAS JMP form, which is the distribution window. So we're going to go to Analyze, Distribution. Now we can check the distributions of any of these, but we will be checking the distribution of weight. So here we have a nice box and whisker plot. We can see all the distributions of data where it's most dense, and we have summary statistics down here that will show you exactly what the mean is, which is that middle line. You have all your quartiles and your whiskers, which is your max, mins, and dots represented by, or dots are outliers. One thing you can do on this is run a hypothesis test. By clicking the red arrow, you'll see that we can test the mean or the standard deviation of the data we chose. So we'll do test mean, and we'll just pick a random value here. We'll see we'll go with 140. What's the percent chance that the mean is 140? And obviously that's going to be a pretty low value here. That was the hypothesis test for the mean. You'd also do a hypothesis test for the standard deviation right below the test for the mean, but we won't go into that yet. Another huge thing in SAS JMP is analyze X by Y. This actually allows you to do a lot of great analysis tools. So if you go back to the Analysis tab, it will go from Fit Y by X. From this window, you are allowed to put things in X and Y responses. Depending on the type of data, it could change what kind of chart it ends up giving you for the output. But we will try comparing some of these continuous variables. So we can compare weight to the amount of chin-ups somebody could do. Now, in your head, the natural thing to think is less somebody weighs, probably the more pull-ups they could do, the chin-ups, but we'll see how that actually works. And from this, we can also click the red arrow and do a fit line. I think this gives you a ton of data. We can see that our assumption is kind of correct, not really. If we go down to the bottom, we can tell if there is actually a strong correlation or not. It fits well. And on this, we see that go to the second value for chin-ups, that the p-value is actually not significant enough to reject the null hypothesis. It has to be 0.05 or lower to reject the null hypothesis, which it is over that by a little bit. So we can try doing a different analysis from our data here. Go back to analysis, fit Y by X, and we'll go for weight and waist. That should be a pretty direct correlation. From here we can see that even without fitting a line, that is probably going to have a pretty significant correlation. We scroll down here and we see that yes, but we can definitely reject the null hypothesis because of super low p-value. We'll continue with the fit x by y, but we're going to go to a new data set so we can complete an ANOVA test. It's also a very important test. So we're going to go back to our sample data, and we're going to go to the data set cars. Scroll down to C, and we'll come across, then scroll past it, cars. And here you can see on the left side that we have more than just the blue triangles, which mean continuous data. We have some ordinal and normal data. Ordinal and normal are pretty similar, and this means that it's more normal means that it could be like 1, 2, 3, and just those 3, or it could be that it's an act or like names or categories. So we're going to do the same thing. Go to analyze, fit y by x. Other types of charts that SAS JMP can make are ANOVA and logistics regression. Now we'll throw one of these normal variables into the x factor, and we'll throw one of these continuous variables in the y factor, and we'll get a one-way ANOVA test. It'll show whatever test you end up doing right down here in the left-hand corner. Last time we did a bivariate fit, so now we're at the one-way ANOVA. From there, we'll click OK. And here we can see all of our different categories here at the bottom, all the different brands of cars. And then we can see their chest decal, which stands for chest deceleration, here on the y-axis. And then if we want to analyze this data, we can go to mean/ANOVA. We get all these different comparison of means. If you can see the green triangles pretty well, that middle line in the green triangle is the mean, and how long the green diamond is the variance, so like the standard deviation. Statistic down here at the bottom, it just shows us that there is a difference between all of our different brands of cars, and this is pretty easy to see by the green triangles. Next, we will go to the same tab and use logistics regression this time. Analyze, fit y by x. And this time we want to use this bottom left one here, logistics regression. So it has this nice chart that will show that we'll need a blue and a green or an orange to use logistics. This model will use to fit an S-curve on the graph with a yes or a no answer. So to get a yes or no answer, we're going to do this D/P, which means driver or passenger, in the y-axis. And then the x-axis, we're going to use chest deceleration again. And we can see that it says logistics regression right here. Well, just the logistics, but that's what it is. So we click OK. See the slight S-curve saying that the chest deceleration of the driver is slower than that of the passenger. We can also see the p-value is low, so that means that there's definitely a difference between the two categories. Next, we'll use chi-squared mosaic plot. We're going to use the Titanic data for this one. So we're going to go to the T's, Titanic data. There. And so we all have, see all these variables are normal. The chi-square test is used when comparing numeric values. This will bring up a mosaic plot, the different categories plotted against each other to see if there's inferences we can be made by the data. At the bottom, you can see that the chi-squared values that show the importance of each category. There is a strong correlation for the categories. The chi-squared values will be low, and if not, the values will be high. For this, we will use a sample data of Titanic. We will put survivors, so we're going to go to Analyze, fit y by x, in the y-axis, and in the x-axis we will put passenger class and sex and class. This is a great chart that we can make tons of assumptions for. We can see that females have a much higher survival rate than males, and that each class you go, the crew obviously is about the same as third class. The first and second class have a higher survival rates than the others. It makes a lot of sense from what we know of the Titanic, that they put women and children on the lifeboats first, and then obviously they go by classes. So you paid more for your ticket, you gotta get on the lifeboats first. At the bottom you see the chi-squared values that show the importance of each category. If there is a strong correlation for the categories, the chi-squared value will be low. If not, the chi-squared value will be high.